In item 1 on the first exam of the spring 2014 course, note that we are asked to find the resultant of three given forces, but that not that we're just supposed to find any resultant, but rather the resultant in the polar form. We're given two of the forces, F1 and F2, already in their x and y component, or their vector component form. That's these two forces to the right. And so ultimately here we're asked to find R equals the sum of F1 plus F2 plus F3. Not the reaction of those three, but rather the resultant of those three. Again, we're already given what the x and y component form is for two of them, so all we really need to do is first find the vector component form of, or x and y scalar components of the third force, and then sum the appropriate components together. Right? For the x component, we have that the 150 Newton force is going to have components that are 150 times cosine of 35 degrees. It's acting in the negative x direction, and so that's why I insert the minus sign, and that will give us a minus 122.87 newtons for that component. The vertical component will be in the positive y direction, so positive 150 times sine of 35 degrees, and that will equal then 86.04 newtons for that component. So that when I come and look at then Rx being the sum of all of the x components, I get then 61.28 from the first plus 41.04 from the second minus 122.87 from the third, leaving a net of minus 20.55 newtons for the Rx component. Similarly, the Ry component then will be the 51.42 from the first plus 112.76 from the second plus 86.04 from the third, leaving a net of 250.22 for the y component. Right. To get then the magnitude of R, all I need to do is take the square root of the sum of the squares of the individual components, and when we do that, we end up with, as an intermediate result, 251.06 for that magnitude. Still need to get the direction here, because again we're asked to find this in the polar form. That means a magnitude and a direction for the resultant force, and so it might be helpful to visualize this to show the scalar components. We have a minus 20.55 for the x. We have a vertical, which is about a 10 to 1, a little more than a 10 to 1 ratio, more like 12 to 1 of y to x. And so the resultant that we're after here, then we just found that resultant. Let's find out what that angle theta is, and that theta is the arc tan of opposite over adjacent, so 250.22 over the 20.55. Note, I'm not going to worry about the minus sign because I'm going to handle that with my reference system. When I do that, I get an angle of about 85.3 degrees. Makes sense because we have a very large angle, close to 90, and where the vertical component is much, much larger than the horizontal component, I should have that angle close to getting close to 90 degrees, but less than. And then as my final answer, then my resultant force will equal 251 newtons, and then it has a reference from the negative x-axis of 85.3 degrees. And there's your answer for item number 1.